Is it working? Is it working?
If not, you cannot transfer. That's just like normal fashion. So is it like I stupid? Is it like aerial or no stupid
这是范围。如果你就是只点了一点，就是到这个地方开始，对，然后你点一下，点到哪个地方你可以。
What can I get keep it? Oh,
如果我点这个地方开始，这个地方可以。我可能是少了这个文件。它是网卡给我，我也不知道为什么放在
我们平时下课会做一个练习啊。
我做了之前，他给我做，然后还有那个
so I wanted to find K group. So finding the last just gap in the data, split data,
就是还有说要扣电波也没有
find the last just gap that has been split and split it there.
就是他
It was one group. It was to get K group.
就是他那些那些
Asking for the input of my number. So not just different. Because
你说太难了，
that's just different between these.
没有了，没了。当我回家的时候有在做，我在看他们在看，就是没有。
在哪？自己去了。
Get between this and that.
Last time we got the same score, Michelle. Last time we got the same score for the quiz too.
哦，这个，但是这很简单，像它是在那 Tapas 里面，就是有一个地方叫 Code Blue， 然后还有一些
你平时讲广东话？
我可以讲啊，我讲粤语比较好。
我会感觉出来，你讲粤语应该会比较好。
有点为难。
家里是爸爸是香港人，然后你妈妈是香港人。
也算是混血了。
你也算是混血。
就是如果在这边生活的话，都是拿泰文的名字，但是回到香港就是。我也有泰文的名字吧？你也有？他妈的
！Just to let you know, if you don't understand things in class, don't feel bad about yourself. Blame me. Because I'm supposed to explain it to you until you understand. But then you have to let me know if there's something else that you still don't understand because I cannot read mine, even though I wish I could. So let's get back to that reference again. Let me bring back the code. So just hang on a sec. Okay, so let's get back to that piece of code. And when you're still confused about that, that's totally okay. So let's talk about binding. So here we establish x, y, and z. So let's talk about x first. So let's assume that here is x. Make it like an object so that you can grab onto it. And then later on, we give x to foo, and it's in the same position as a. So now, it's not that x is the same as a, but x and a are referring to the same bag.
the data
So, however, later on, in the first line in foo, we said we don't like the old bag. We want a new bag
image
that contains 4 and 5. And we're
is
gonna make
index.
A be the name of that bag. So
And we can
now
go
this
to
is still X, but now
if
A now referring to another bag. List of X, list
we
of
can
A.
set previous
So at the end, when you return back from foo, what is X? Still this old bag.
data
And A, like Nata just
plus
asked,
1
which is a really good one, A just disappeared
minus
because we end the
data
function. So yeah, cool. Go on, good.
I.
Yeah, so that was a good question. How about B?
Okay,
So
so we
B,
take the next
similarly, in
index
this way,
minus the first index
Y
and that's
is
the previous different.
assigned to a list. Let's say this back. And then we bind B to the same object as Y. So now this back got two names, Y and B. And later on we said,
If
let's
the total
add something to this
previous
bag.
equals 0,
So let me add, what do I have? Okay, I have the remote control and it does work. Let's add something to the bag. Let me add the remote control to the bag. So now, Y has
this
a
can be
new
current
object as well as B because they're the names of the same
this
bag, which is different than the first situation because the first situation we said
previous
we're gonna make A be the name of another bag instead. So now are you clear? And how about the last one? The last one, I'm glad I got to talk to Mancha. So last one, it may seem like we summing something to one, but don't forget that one is not a variable. One is a literal. Literal cannot be changed. If you want to sum one to one, you generate a new object which is two. It's not
we
the same
store
object. So
this
at the end, z is still referring to one. You cannot change the literal. Okay, sure. So for this one, C is referring to one, and C is referring to one as well. In the code, we said we sum 1 to C. But when we sum 1 to C, of course, we want to sum 1 to C, but 1
also
here is
equals
not a container, it's a fixed value, which is 1. That's why once we sum 1 and 1, we're going to have a new fixed value, which is 2. And C here will have to change its reference to point to the new fixed value 2. Is not equal. So we use the equal sign, but it's not equal. C is referring to 1. Huh? Why? Because the code said so. Here, C is referring to 1.
we can
And here, C is going to refer to the summation of 1 and 1, which is 2. Oh, maybe Mancha could help. Mancha, do you understand this at this point, right? Do you want to do it now? Do you want to do it later? Okay. Yes. Do you want my money?
So you get a negative 1.
But I think it's good, yes. So because summing 1 and 1
Plus
create a new object, or we can say that 2 is not a new object, but just to say that this is 2. So C has to change the reference to 2. While Z is still pointing to the same thing. Because Z and Z are not the same. But let's Manchat of Busanita later. Maybe. Yeah, she said later. So maybe later after class or during the break. Thanks a lot, Manchat.
plus 1.
This thing. Why do I have to fight with this all the time? I turn around and change the mode. Okay, so today we're gonna learn about recursion. And as usual with this special function, they're special. This means they're especially difficult and they're especially useful if you can use them. Similar to set the dictionary. So recursion actually is a specialized type of function call. That's why we have to go through this and we will have to understand the concept of function call because recursion
So I
is
start from 1.
a bit more complicated function call. Actually, recursion is not a concept in programming. Recursion is already a concept in nature. I don't know if you have heard of the word fractal art. It was really big when it was your age, where a lot repeated images are drawn over itself, but getting
So
smaller
12,
and smaller
10,
and create different shapes and
4,
different
5, 12.
like type of visualization. But here is just one example where you draw triangle over and over within itself. And each time you draw the triangle, you draw it inside a bigger triangle and make it smaller and smaller and go inside one another. If you love them, search for more. For like fractal art libraries, you're gonna find more of repeating patterns like this. But then how does it work? It works by repeating itself, but scale itself down to fit in the bigger object. So first we have a big triangle. We scale it down by half, turn it around, fit it in the bigger triangle, and then in each sub-triangle, we draw more triangle. And then we draw more triangle in each sub-triangle. And every time we do, we got smaller and smaller triangles. And that's the concept of recursion. And actually, you see the same concept in the nature. We borrow this from the nature. For example, my favorite vegetable, broccoli. Oh yeah. Actually, broccoli is like kind of recursive structure. It's like the little tree inside the big tree, and then you can go in and you can buy little trees. Let's say. And actually, when we talk about broccoli, I don't know if you have seen this before. I actually ran into one in Germany and I got it and cooked it just for fun. This is the actual fractal in the nature. It's like the little tree within the little tree and within the little tree. Let's create a bigger tree of the same shape. It's it tastes like broccoli. How to describe it? So when it's come to function, it's about the same idea. That is the concept of repeating itself into itself when we talk about recursion. So, but let's start from a simple function call. We have done that before, recalling function inside function previously. For example, here we had A05 function foo, and inside function foo, we call the len function to do the work. And we have done that many times before. And you can call the built-in function in Python or during the assignment and the mastery exam. I think some of you, hopefully all of you have called the function that you make yourself within the function that you make yourself. So a recursion is a special type of function that you repeat it. You repeat the function within the function itself. So here you see the definition of function countdown. And then inside the function body, you will find that this function is calling itself. So we're going to go down and down, like what you see in the triangle. So what's going to happen when we run this? So let's run the definition first, get it into the system, and run countdown. So once we run it, you see what is printed first. 2 is printed because when we get into here with 2, n now is bound to 2. And then we check if n is equal to 0, which is not. So we have to go to the else block. We print 2, and then call the next countdown with 2 minus 1. So now we're going back, similar to loop. It's like a special form of loop. And then n is still not equal to 0. So we have to print 1, subtract, and send it to the next countdown. So even though now n is 0 here, it doesn't mean that we can stop here, because here is not the check. The check is when we go down again. So now n will be 0, and 0 is equal to 0. Now we can print new launch. And since once we finish the if block, there is no other lines of code for this function, we exit. So this tech print, this is another type of function where you might not explicitly return anything as well. But a lot of time we return something from the recursive function, but we don't have to. Yes, Ina? Yes, if you print the return, if you print a function, that's actually what somebody mentioned before. If we go back to function foo in the quiz, if you print foo, what are you going to get? None. Because the function doesn't return anything. So here function print, but function doesn't return. So you will get none as well.
What if I do data 1 minus
然后就是出现那个东东，那你还没发这个发号码，就是这个我们要填进去。
Maybe you can show me the code better. Can you rectify? And that's normally why I like to hear you guys discuss as well, because it's a different way of explaining. Like when you talk about Bob 1, Bob 2. Yeah, that's what she said. So actually in Should I explain that one? It might be more complicated, but your concept is right. Actually, a function is like a variable as well, the function name, because it's holding the reference to the block of code that do the work. So actually, countdown is referring to a block of code that does the work, and you can, if you want to, associate a value back to that when we return. So in this case, there is nothing that's going to be returned. It's bound with this function. So when you print, nothing's going to be printed. Have you tried to print? Yeah, try it. Print of print, what do you get? Actually, I think that's fun.
Something like this.
None. Yes, why?
Right. Follow.
Exactly. No, you can. So if we print A, we got A. But if we print, why don't we get A?
1, 2,
Here, we got none.
and
We got A and none. Because here, print A, the task is to show A at the console. Print itself doesn't return anything. You think it's return, right? When you see A here, it's not. A is printing this to the console. It doesn't return. It might appear as if print is returning something, but it doesn't return anything. So if you check print of print, you get none. But it just print, it doesn't return. Not quite right. I think at the end of the class, we'll have three ladies knowing each other, which would be really nice. I think but that is very nice. That means you have something to share and exchange and get everybody to understand the material better.
do this first. So this will be
I'm gonna pause here for a second for
let's do the 2. Then just do this will be minus 2. This one.
I missed that conversation. But I can catch up with you. All right. So here comes the breakdown of the recursive call. Similar to the full function, every time you go down the recursive path, it's like you have a mini world inside inside, and then if you call it again, you have the mini world inside the mini world. So we have the mini world inside the first mini world with n referring to 2, and then within that block you have another mini world of n referring to 1, and then innermost block n is referring to 0. Once you're done, and then you return back from the function, you will go back, similar to the function call, you will go back to the line right after the function call. But in this case, there is nothing after the condition, after the decision, so you will have to go up and go up and go up until you reach the top of the calling change, which is countdown 1. So I think it's good that Diana mentioned that, so that we differentiate between the flow of execution and the value that
What
is
is skip
captured.
somehow?
Yeah. Sorry.
What to do? Skip here. Okay, so we take the data
So in this case,
minus
you have
this plus
countdown
this.
2, and then we said we reverse
5
down
minus
to countdown 1,
22.
and we reverse down to count down 0. And then once we get there, we're done. And then you have to return back up. When we return back up, is anything returned, Diana? We said we return back up to countdown 1, but is there any value return back up? The flow of execution return out, but is there any value that is returned out as well from this function? Is there any return statement? No. So should there be anything returned back? Nothing. But the flow of execution go back up. But no value is returned back up. Two different things. So none is returned, but the flow of execution return to the caller. Okay. So let's say that to help us understand the recursion further, let's add another line. Let's print another line. That's the only thing that is different. And then let's run it.
Oh, this is the
Change the function, print again. And then now you can see the flow of execution better, that we go down, and then we go down, and then on the on the way back, then hold on, let me think. Okay. So for this one, once we go in, we print 2. And then we call countdown function. So we go into this block. And then we have countdown 1. Then we have to go into this block again with countdown 0. Then once we have that countdown 0, we print no launch. And then once we return from printing this no launch, we coming up to countdown 1. So that's why here print finish with 1 is printed after no launch. And once that one is printed, we return back to the same code of countdown 2. So that's why this one is printed with finish with 2. It's the flow of execution. So you execute the same code. This means when we do this function, we have 3 copies of the countdown function in working. And in each function, the processor keeps different types of value which differs in each copy of the function. So for the processor, it will take a look at this as 3 different things. Just that these 3 different things got the same steps of code.
So find the difference.
Like 3 mini words separately.
Right. Let's split it.
This person doesn't. So either you can try this with the visualizer, or another thing that you can do is to help you understand some recursive function, add some print to it, print line to it like this one, so that you can watch the flow of execution if it's what you think or not. But then let me ask you a question. Can we, for example, if we put this one up here, are we going to change the order of execution? Hold on, okay. So are we going to get the same thing printed out, or are we going to get different order? Let me put that in the block, so that we have the results from here. Tab, what do you think? We can get the same thing, or are we going to get different thing? Kind of like same. So let's try that. Is it the same? This one. Actually, one more is added because now that line is not in the else block anymore. So every loop is going to be executed. So you got one more line added to it. what you have to be careful as well, which code is done under which condition, go line by line and go slowly. And this is normally recursion is the part that sent me to scrap my restroom when I was in school, because sitting down at the computer just thinking about this made me go crazy. So I normally like go cooking, go clean the house while I'm thinking
The
about
timing is
recursive function and
fine,
come back to
and
code it. But
let's
that's up to your thinking style.
suppose
So so when we change that back to the flow, every time you return, there's still one more line waiting for you. Oops, sorry, this is a typo. It should be the parenthesis. So every time when you return from one, you need to print, and when you return from two, and then you return for two, and that's all. That's the end of the line. Because the print is in the else block. So in the big world, we don't have to print everything. Of course, it's easier said than done. So let's try the exercise. And I'll give you 10 minutes for that. Then we'll come back. And so that you have time to catch up with each other on the part that you still don't understand.
so I would need to do x plus 1 splitting of this.
So my hint is you need only two changes. But why do I say two changes in three places? I'm confused with my own hint, but not a lot of places that you have to change.
Next split.
I understand. Three small changes in two lines.
Let's do this. So just do so T1 equal data to x and G2 would be get around. And but split 44. No, this one. So -1. No, I should do it the other way around.
is here. Taradon. Right. Yes.
I know to split the leaves. So the index of the max difference is 44. Let's put this as index 3. I've got the data for index 3 be 0, 1, 2, 3. So plus 1. Yes, okay. So what it was 1. And then, so group 2 will be next group. Then we do group 1 and we take group 1 we do the same thing. So we'll do group 2 first, which is the highest group.
Oh, what movie is the H1? Okay, sorry, I got it mixed up. Jirasa is here, Natapat is
So I would append this into
Samuel is here, Pinada
this.
here. Hatira is here. She is here and says here. Email 1, 2, 3. No. Thank you.
And then we would, so I don't need this anymore. Now for G1, what we want to do is make this equal data. I need this to go back to the for loop.
Because at the beginning, there is only one.
I put this in the for loop. It allow free because I reset the data. So we go through the entire list, find all of the difference.
It just changed it. Yeah, so the tree will reference several containers, 15 literals, 15. container is like a variable.
Listen to return for here.
So here, it's the same problem
Next, next if taken data is this of 8 return it.
Oh, that's a good question. So where is the limit? Where do we set?
Okay.
So similar to what you have previously within loop, same difficulties like Tat just mentioned, that you need to be able to specify the condition to make the loop going as well as the condition to stop the loop.
Data.
So here you can imagine that this is where we stop counting down. So should we change that one to stop going up? And what else do we have to change other than the functioning?
Oh, but there's only 12.
Tanade. Okay, Tanade, where should we change to make this code work? Let me go back to that one. Gosh, I have too many tabs open. I'm confused. Okay.
Oh, just take 12.
Oh. I love that explanation.
I should do this. I equal k minus 1. Everything. Else. Just a normal one.
This is not Halloween, but they're still doing this to me. I think could be because this one overheated or something. Like I noticed that after using it for like 2 hours, it's doing weird things on me. Like this, it doesn't go in, or once it go in, it's green.
Is it the same task?
The green screen.
Holy shit.
I know it's not Halloween. Okay, then I did. Tell me. Why do we have to
I put in
change?
the wrong place. yes. Going to
On the if statement, so we change it to count up.
okay,
And then,
done.
okay, so at least you know we have to change. So at least you should change the function name to count up. But in many places, do we have to change count down to count up? Can we just change the first line? No. Where else? Last line. So let's do that. Sorry for my green screen. I'm going to buy a new one. Okay, but this doesn't make it count down or count up yet, but at least we are preparing the function. Maybe. Architect could help. So what else do we need to change? Other than changing the function names? Function name in two places. So that was right. You have to change the stop condition. According to the problem, what is the stop condition?
Nice. How it took.
I really had the green screen.
46 minutes.
Can we compare end to end? Because the problem said you should print from 1 to end. Can we? I did, but it didn't work. Yeah, so it shouldn't work. We cannot compare end to end because in the same scope, end is end anyway. So when you compare that, it didn't work. So when you think that shouldn't work, then what should be the easiest solution? Similar to what I have told you before, if solution A doesn't work, think about another solution. So let's leave the condition the same. What else can you change other than the condition? The code is small. Maybe you can guess. What else can you change? If you want to leave this part the same, there are only two things that you can change. This line or that line. Which line that you want to change? So do you want to change this line? To what? To what? So if you plus 1,
didn't pass the test.
we're going to get infinite loop or
wrong.
infinite recursion. So now there's only one place that you haven't think about changing. And actually I like this small exercise because think about the unthinkable. There's not many things to think about, so why not trying it out? Well, it's green and see how it works. See if it will work. Does it work? So, and this is what another difficult thing about programming, that if you haven't tried everything, don't give up. But you have to have a systematic way of trying things. If this doesn't work, let's try another thing. If that doesn't work, let's try another thing. But you have to keep tab of things that you have tried and haven't tried. But believe me, the first time I see this problem, I try to do the same thing like you do. Try to compare and then I was like, no, that didn't work. So I have to think about another way. But if you don't get recursion in one go, like I said, don't beat up yourself. It's something that it needs to sink in, and you have to look at a number of examples before you understand the concept. So, similar to what you have pointed out before, if you don't specify the stop condition and the condition that make it go incorrectly, you can get stuck in the infinite loop as well.